Welcome, friends, to this new series of learning containers and Kubernetes. So, in the last couple of lectures, we saw how we can run the containers. Specifically, we ran Nginx and MySQL database servers as a container. So, we spinned up a couple of containers, and in the upcoming lectures, we will see how we can deploy them in production. But before jumping into that, we need to understand the networking concept of Docker containers so that we can securely manage those containers in a real production system. So, as usual, the network means the isolation of the systems. So, you can consider this is the host machine where we are running 4 containers in it. But how about their communications? How we can isolate them from one another and how we can try to communicate within themselves very securely and privately. So here in this particular slide, you can see that we have logically divided these 4 containers into 2 separate groups, and each of the groups you can consider as network. For example, these 2 containers belong to a network A, and these 2 containers belongs to network B. Now, within this network A, both of these containers can communicate. They can talk to each other, but they cannot talk to the other containers in a different network. So in this way, we can isolate these networks and isolate the communications and how they can communicate with each other. Now, this particular user can reach to any containers depending upon their nature. Maybe this particular container is mapped to this port and the user can access this container via this port. Now this port is mapped from this machine to this container. Similarly, other cases are true. Also, there is a volume map of this particular container of a particular file system to a file system of the host. So in this way, we can manage these networks internally to have a network layer. Now we can go ahead and jump into the console to see how the network actually works. But before that, we need to understand how many types of networks Docker supports and what are actually they. Now, currently, we are having total 6 kinds of networks that Docker supports. The bridge is the default one. If you don't specify a driver, this is the type of network you are creating. Bridge networks are commonly used when your application runs in a container that needs to communicate with other containers on the same host. Now, this host type of network removes network isolations between the container and the Docker host and use the host's networking directly. The overlay actually the networks that connects multiple Docker daemons together and enables swarm services and containers to communicate across nodes. Now, we will discuss about the Docker swarms in the upcoming lectures. This is just an overview what actually the overlay actually plays in the networking. IP plan. This is the IP plan networks give users total control over both IPv4 and v6 addresses. The VLAN driver builds on top of that in giving operators complete control of layer 2 VLAN, tagging, and even IP VLAN L3 routing for users interested in underlay network integration. And finally, this MAC VLAN network allows you to assign a MAC address to a particular container. making it appear as a physical device on your network. The Docker daemon routes traffic to containers by their MAC address. Using the MAC-BLAN driver is sometimes the best choice when dealing with legacy applications that expects to be directly connected to the physical network rather than routed through the Docker host network stack. And we left one networking that is basically completely isolated network from the host and other containers. And none is not available for the Swarm services, definitely. And this is basically nothing about the network. So now let's jump to the console and see how this networking actually works. Okay, friends, so this is our virtual machines host where we ran our Docker containers in the previous lectures. So we created MySQL servers and some Nginx 1, 2, and some Nginx containers. And if you have missed those videos, maybe you can watch those videos right now. And we're going to provide the link of those videos descriptions below. Let's create our network in Docker. So it's very easy to create a network in Docker. It's just Docker network create, and then we can name the network. For example, we can say the network name is mynet. And if we do so, our network got created. Now, how we can see how many networks we do have right now? So it's again a very simple command, Docker network list. So you can see that we just created the mynet network. And as we did not specify any kind of type, what kind of driver it should be, so by default, the bridge network was selected. Now, you may wonder that we already had a couple of networks that was created by the Docker engine when it was installed in the system, and their bridge, host, and none. So by default, any container was running in the bridge network. Now, we have created the network mynet, and we can use the Docker run -d, and then we can specify the network, which is minus minus network, and we can say our network is mynet, and then we can name our container as, say, for example, some nginx net, and then we can say nginx, and we can run our first nginx container inside the network mynet. Now, this particular nginx cannot communicate with these nginx because it's in a separate network by default. Unless we can tie this network, they cannot communicate. So nginx, some nginx net is basically inside the network of mynet. As this particular network is being used by one of the containers, we cannot directly remove this network until we are going to remove this particular container. So if we say Docker rm mynet, it will say that it is being used by one of the containers. So if we remove this container, some nginx net, and then we can successfully remove this network. Now, if we say Docker network minus minus help, it will give us the commands those can be used after network. So there are a couple of commands like connect to connect to a container to a particular network. We can say create, disconnect, inspect, ls, prune, and rm. So create, this is what we just used. So connect, if we want to connect these previously running containers like SAM-Nginx or SAM-Nginx1 to this network, mynet, we can use this connect command. So we can connect to a existing container to a particular network through connect command. We can use create to create a new network. We can disconnect the container that is actually connected to a particular network. We can use disconnect command. We can inspect to understand what is the detailed information about the network. ls is just the list containers. We can use list list as well. We just use this one. We can use prune to remove all unused networks, and we can use rm. This is just what we used a minute ago. Now, let's try to see what exactly the other things over there in the network create command. If we say network create help, it will specify a couple of options. Apart from these, you can come across these minus minus internal if you want to create a private network which is not accessible from the external world. And in the upcoming lecture, we will play around with internal network. Apart from that, we can use a subnet to create a CID range, and we can create subnet inside the network. So let's go deep what exactly the subnet in the upcoming lecture, where we will actually use a segregated parts in a particular network to isolate them from one another, and we can provide a CID range for those subnets. Thank you for watching this video. We hope that you enjoyed the videos a lot. In the upcoming lecture, we will see how the subnets can be implemented, how the private network can be implemented to secure our database from the external world, and how we can securely communicate within the networks, and the external world cannot reach to that particular container if you want to hide that container to keep it a very secure way. So we will see all these things in the upcoming videos. So please stay tuned and be safe. Thank you. See you in the next lecture.